Very good evening, everyone, and welcome to the Hibiscus Coast Astronomical Society meeting. And of course, today I've got a really good speaker, John Drummond, who will be popping up a bit later. So what we're going to do is we're going to start off with the news with Josh, and we'll then go on to John's presentation. It's going to be pretty good because we're going to have some live telescope demos going as well. So there we go. So I'm going to hand it over to Josh, and I'll chat to you in a bit. Unmute, Josh.
Of course, thank you. Thanks for reminding me to unmute. Thanks everyone for tuning in to join the Hibiscus Coast Astronomical Society virtual meeting. This is, I think, our third or fourth meeting now, so obviously we're still getting the hang of things. But yeah, let's see how this goes. I'm going to run us through the news, what's been happening recently. So I'll just share my screen. So let's start with the astronomy news. What's been happening above us? So first of all, we've got a historic space flight to the International Space Station happening next week. So this will be something to look out for in the news. In this flight, the SpaceX Dragon shuttle will carry 2 astronauts to the International Space Station. So you might think, well, why is that important? You know, that happens all the time. The reason it's historic is that this is the first SpaceX mission with astronauts on board. So SpaceX has been operating for a number of years now, getting better and better at spaceflight. They've got a prototype shuttle, which they call the Dragon, which is designed to carry people, and they've done test flights of that uncrewed. But this will be the first actual flight of a SpaceX shuttle with people on board. This will also mark the first human spaceflight to launch from US since NASA retired the Space Shuttle program back in 2011. So since NASA retired the Space Shuttle, every time they need to send people to the International Space Station or back, they rely on Russia to help them out. So that's another reason why this spaceflight next week is quite important, quite historic. So the astronauts will spend about 1 to 4 months in space, and the shuttle will stay in space as well. So this I found kind of interesting. When I first heard about this, I imagined the shuttle would be sort of like a taxi. It would drop them off and then come back down. But of course, that wouldn't make sense. So what happens is it goes up there, the shuttle will dock with the space station, and the shuttle will actually remain there, sort of docked in the space station itself for the 1 to 4 months. Next week is quite, the research is done and it's time to come home. And then they'll come back home. The shuttle will return to Earth and it will deploy a parachute and then land somewhere in the ocean. So yeah, this is something to look out for in the news. Also on the topic of space travel and space exploration, NASA has unveiled what it calls the Artemis Accords. So these are guidelines to facilitate international exploration, science and commercial activities in space and on the moon. So if you think about here on Earth, how we have this concept of international waters, parts of the Earth that don't belong to any one country, but we still have accords and laws and guidelines about how we expect countries to act in international waters. Well, NASA is proposing the same sort of things for space, which are called the Artemis Accords, because this ties into the planned Artemis moon missions in 2024. This outlines all sorts of things like that countries shouldn't interfere with what other countries are doing on the moon or in space. It even outlines things to do with space mining and how we should do that in a responsible way. At the moment, no other countries have signed onto these accords yet, but NASA hopes that in the lead up to the moon missions in 2024, as they partner with more countries, they will get other countries to sign up to these accords. So it'll actually be an international effort. Mars could have mud volcanoes. So Mars has tens of thousands of hills topped with craters, especially in the northern hemisphere. Craters that look a bit like this from the top. And we've long wondered what these are, and there's been a theory that these could be mud volcanoes. However, it's hard to prove this because we don't know exactly how mud flows on Mars. It's a different planet, different environment, gravity, that sort of thing. However, there's a new study that has looked at the way that mud flows here on Earth in a controlled environment. And what they've done is they've set up like a big container with the same sort of low temperature and low pressure as Mars. So this gives us a way to sort of estimate how we think mud would flow down a hill on Mars. And what we've found is that in this really cold temperature, as soon as you pour down this mud and it starts to flow, because it's so cold, it starts to sort of harden and freeze on the outside, but the inside is still liquid, and that sort of pushes through. And you end up with something that looks a bit like lava flowing. So this doesn't, I guess, prove definitively that these definitely are mud volcanoes on Mars, but this is a big step towards that argument. That this makes us think, yeah, maybe these are actually mud volcanoes, similar to, on Earth we have lava volcanoes and mud volcanoes. Scientists discover a super-Earth planet in Earth-like orbit. Now this was interesting because it was actually discovered by astronomers at the University of Canterbury here in New Zealand. Now this was found 25,000 light years away. It's 4 times the size of our planet, and it orbits a brown dwarf, so a very different type of star to ours. And the distance away from the star is about the same, a distance between Earth and Venus. So like if this planet were in our solar system, it would be between Earth and Venus. What's interesting about this is the way that they discovered it. So this was found using something called gravitational microlensing. Now, what this is when you have a very large object in space, a very massive object like a star, it's so big that it actually warps space-time around it. And if you try to observe something and one of these massive things sort of gets in the way, that comes between you and the thing that you're looking at, it can warp what you're seeing and make it look different. And with this method, we can actually identify stars. So we've used this in the past to identify single stars. But this is one of the first times we've actually used this technique to identify a planet. So it's quite exciting. And in terms of exoplanets, from what I understand, this is quite rare to find a planet like this. So that's really interesting news. Closer to home, the North Magnetic Pole here on Earth has decided to leave Canada and move to Siberia. So here on Earth, our North Magnetic Pole moves over time. It sort of wanders around a bit over years. So it's not always in the same place. We first discovered this in 1831, and from then to 1990, it's moved on average around 15 kilometers a year. But then in recent times, it started to speed up a bit more, and now it can sometimes move as much as 60 kilometers a year. And we've noticed it sort of seems to move around between sort of Canada and Siberia. We weren't quite sure why, but new research has found that there are 2 giant blobs of negative magnetic flow. This is underneath the Earth, a sort of core mantle boundary. And these blobs are underneath Canada and Siberia. And so now we're thinking that this is what is sort of playing tug of war and moving that magnetic North Pole around. And it looks like that in terms of that tug of war at the moment, Siberia is definitely winning. So it's moving in that direction. In other news, NASA's solar probe plans to gather more data than it ever has in a marathon observation session. So this is in regards to the Parker solar probe. This is something that was launched in August 2018 for a planned 7-year mission. And as part of this mission, it orbits the sun several times, and as it goes past, the plan is to observe the sun. When they first set up this mission, the thinking was every time it orbits the sun, maybe they'll be able to observe for 11 days or so. However, they found that the instruments work really well, and so this current orbit they're planning to observe for almost 2 months. So this is the longest continuous period of time that this particular solar probe will be gathering data and looking at information. And in this particular orbit, the closest it's going to get will be on June 7th. It will be 19 million kilometers away from the sun. That still sounds like quite a big distance, but it's relatively close in terms of what we're talking. By the end of this particular mission, the closest it will get to the sun will be 6 million kilometers away. And this is looking at information to do with solar wind and the sun, all sorts of data for us that is useful for us to help understand the sun. Finally, in other news, as part of this whole COVID lockdown, a lot of us have been in isolation and quarantine. Well, if you're the sort of person that likes to be isolated, maybe you can volunteer for this experiment. You'll be isolated for 8 months. So NASA is seeking volunteers to self-isolate in a Russian lab. This is all part of an upcoming NASA-Russia experiment to study the effects of isolation for space travel. Because if you think about it, going forward into the future, if we want to actually travel out into space more, colonize Mars, all those sorts of things, an important part of that is to understand how are we as humans going to cope in these really long trips, isolated in this small, cramped spaceship. So this particular facility that you can see here, this is in Russia, and this was used in 2011 for what's called the Mars 500 mission. In this particular mission, crew spent 520 days in this facility in one stint, and then 105 days in a separate stint. So yeah, if you're keen to be locked away for a while, maybe apply, but you won't be able to lounge around and watch Netflix the whole time. The crew will live together in isolation and work on scientific research. So there will be some work done there as well. And finally, the image of the week, we have a new, interesting, detailed view of Jupiter. So this might look quite different to the images that we're used to seeing. So these are some more high detailed images of the atmosphere. I think in this particular one, the color has sort of been cleaned up so that we can see the atmosphere a bit more. That's why it doesn't look like the typical orange that we're used to seeing. But it's fascinating looking at the clouds and the way they swirl around. And these are some of the most detailed images we have yet of Jupiter and its atmosphere. And so that wraps up the astronomy news for now. So I will stop sharing. And so I will pass us back to James, or to John. Shall I pass it directly? I'll pass back to James.
Oh, thanks a lot, Josh, for that. That was quite interesting, especially about the Mars part of it. We've got a guest speaker coming up in not the next meeting, the one after that. And she was actually part of one of these Mars habitat experiments before. I'm sure she'll mention it. But it's a bit of a sneak preview at that. I also just want to mention that we might have a couple of international visitors today, thanks to Auckland International Innovation Centre, who have kindly put the word out as well, and thanks to G-Way for sorting that out. So we've got John Drummond with us today, who is from the Gisborne Astronomical Society, and he's been fascinated by astronomy from a very young age, and he's worked his way up. He was a director of the Royal Astronomical Society of New Zealand astrophotography section for 13 odd years. From 2016 to 2018, he was the president of RASNS, and I think is currently the executive secretary still. So been quite involved with that. He's a graduate of Swinburne, much like Chris, where he received his Masters of Science in Astronomy. And in 2019, he was made a fellow of the Royal Astronomical Society of New Zealand. and he's currently doing his PhD in astronomy with the University of Southern Queensland. So he really knows his stuff. So I'm going to hand it over to John, and take it away, John.
Okay, no, thank you for that, James. So hello everybody. I'm here in Gisborne, and basically what I thought I'd do is just show some photos of my equipment, telescopes and so on, and then show a couple of photos of a comet that's been in the morning sky, Comet Swan, then look at a few other photos of other comets that have graced our skies, and then basically show some astro photos, and at the end show some of the science that I do here at Possum Observatory in Gisborne. And if we have time, it's a clear night here in Gisborne at the moment, and if we have time, maybe people might like to say, oh, my telescope's photographing and I can stop what it's photographing now, and someone might say, oh, can we go to Omega Centauri? And so I'll slew the telescope there and take like a 10-second snapshot, and we should on the screen be seeing what's happening with the telescope out there as it takes photos of the targets that some people might volunteer. So I'll just share my screen. Okay. Chris, is that all right? Josh, James, can you see that? I think you're muted. Okay, thanks, James. All right, so I'll just show you the photo, basically where I am. So, of course, you know, New Zealand, and Gisborne is over here. And basically, I live about 15 kilometres to the west of Gisborne, out around about here. So I've got 2 acres of land, got a couple of sheep on here. I school teacher by day, and Gisborne's also got some really good surf breaks, so I tend to go surfing when I can, as well as doing astronomy. Now, let's see how we're going to. Oh, yep, okay. So here's my setup. Can I get? Oh, yeah. This basically, I've got a few observatories here. This one here, this whole observatory actually rotates. It's sitting on a pea combine harvester ring, and so I think there's a photo coming up soon that will show a closer up view of it. Here's one of the telescopes. It's a 14-inch or 35 centimeter f10 Meade Schmidt Cassegrain, and that's sitting on a Paramount MX mount with an S-Big STL 11000 CCD on that. Basically, it's a full 35mm chip. And so with this setup here, I tend to do quite a lot of astrometry, which is where you photograph comets and asteroids, and basically you work out like the longitude and latitude in the sky where they are. And these observations are sent to the Minor Planet Center in Massachusetts in the United States, and basically they're meshed with other people's observations, and then the orbits of newly discovered objects can be determined if we get enough data points. Here's another scope. This is a 41 centimeter, a 16-inch f4.5 Meade Newtonian, and that's sitting on a Paramount ME mount, and basically there's another CCD there. This is the rotating observatory. So if I leaned hard enough against the observatory, the whole building would actually spin around. So it's quite different. Normally it's a dome or a roll-off roof, but this whole building sort of spins around. So that's been fun to use. And that's the telescope inside that rotating observatory. So this roof part here will slide back. One goes that way and one goes that way, and then you look through the slot. And of course, when you want to look somewhere else, you just lean against the wall, stand on the blue floor, lean against the wall, and away you go. It rotates to where you want to go. Okay, so that's that folder finished. Now, just show you some photos of Comet Swan that's been in the sky lately. This was discovered a couple of months ago and photographed by the Solo basically observatory, and an amateur astronomer, Mike Matiazzo in Australia actually saw it on the Swan images and brought astronomers' attention to it. So it wasn't named after him, but it was named after the detector that actually photographed it, which was the Swan Observatory, Swan photos. It was quite nice. It got up to about magnitude 5. It was a morning object target. And we're talking up until about, a week or 2 weeks ago. But now it's actually left our skies and gone into the northern sky, so we can't see it anymore. But from the looks of it, we might have had the best look at it. It seems to have had a nice tail and been pretty bright then. Since then, I think it's died off in magnitude and brightness by about half a magnitude. But it had a nice tail. You could quite easily see the comet with binoculars. In fact, you could see it with the naked eye, just as a very faint little fuzzy patch in the sky. But it was nice to actually get a naked eye sky object in the sky again. Here's another photo where I just really, using Photoshop, just really stretched the image to just try and look at this little nobule in the tail that sort of kind of detached from the tail. This photo here was taken with a 70mm lens, and I just wanted to see how long the tail possibly was. And in this photo here, the tail was actually 12 degrees long. So if you don't know what a degree in the sky is, the full moon is half a degree across. So if you've got two full moons and set them side by side together, from one edge right over to the other edge of the two moons, that would be 1 degree. So you could actually fit 24 full moons along this tail here. So it was quite a long tail. It was nice to see a fairly decent comet with the tail. And this was just with a DSLR camera, not the best photo. It was pretty low in the sky at this stage, but again, you can see the tail coming away, and through binoculars, it was fairly easy to actually see the green color of the actual comet. So that was nice. Now we'll just close that, and I'll just show you some photos of some other comets that we've had over the years. This one here was quite a famous one, Comet Lovejoy. They called it the headless comet. It didn't really have a head, but it had a really nice tail. And just for comparison, here's the pointers in the Southern Cross, Epsilon Centauri, Omega Centauri, Milky Way coming down here. For those who know Gisborne, this is Yunnanock's head here. The story is Captain Cook, when he was sailing towards New Zealand after the 1769 transit of Venus, basically said, first person to see land, I'll name it after you. And a 12-year-old cabin boy called Nicholas Young saw land. So Captain Cook named this peninsula after Nicholas Young, and it's known as Yunnanock's Head. For those who know John Burt, he's since left Gisborne. He's in near Nelson now. That was him, and yeah, we had a nice night observing the comet that night. This was back in 2007. This is Comet Nort, and this is after it had its best glory time. By this stage, it was in the morning sky. Well, basically, it was circumpolar, and this was taken at Opotari Beach in the Coromandel, and the night was quite bright. There's quite a bright moon in the sky, but it's quite neat to actually get a photo and put people into the photo with the comet. It adds a bit of life to it, and also gives you a bit of a comparison about how big the comet was in the sky. Bouncing around a little bit, this is Comet Lovejoy again. Now, this is the International Space Station coming down here, and it's basically met the comet here. It was quite neat. The Griffith Observatory, the Griffith Planetarium in Los Angeles, got in touch and asked if they could put this photo on the cover of one of their publications. back to 2007, this is Comet McNaught, and this was taken during the daytime. And this is when the comet was about 3 fingers away from the actual sun. So it was quite neat, just lying down in the under the roofing of the house to block out the sun, and to be able to look up and actually see a comet in the daytime with the tail coming away from it was one of those rare occasions. They recommend, they suggest that people might see a naked eye comet once in their life. So this is my chance to see this one here. So that was back in 2007. And again, Comet McNaught put on, this is about a week after that photo during the daytime, it put on this beautiful display with a lovely tail. That was taken at Tuki at the Central Star Party, known as Stardate back then. And this photo here is basically a number of photos of the comet which are stacked on the head, and you can stack a number of photos on stars or on the head of the comet in this case, and then once you do that, you bring out what is called the signal to noise ratio. And I was trying to bring out the signal to noise just to try and show some of the structure in the comet's tail. It's quite neat, all these little striations coming up here from the comet. That was McNaught taken through a telescope, and you can see how brilliant the head was. I mean, most comets through a telescope are little fuzzy blobs, whereas this is just lovely to look at, just beautiful. Okay, and one comet, the last comet I'll talk about here is Comet Schwarzmann-Wachmann 29P. This comet resides out between Jupiter and Saturn. It actually doesn't come in close to the sun for a perihelion passage. It's pretty much in a circular orbit, but now and again, probably every couple of months, it will undergo a cryovolcanism event where basically material in the comet will just erupt, and it'll spew out gases and so on, and form a coma around the comet, and it can increase in brightness from magnitude 15 and a half, 16 and a half, up to magnitude 12. So it can get bright a lot fast, pretty fast, just in a matter of hours or a day. So that's quite an interesting one. The British Astronomical Association have asked volunteers to photograph this comet. So I've been doing photographing Schwarzmann-Wachmann for them for a few years now. And I think that's the end of that. And now we'll just go to these other photos. Okay, these are basically just for those who know the Southern Cross. Here's the Southern Cross here. There's one axis, and here's the other axis here. And this here, this dark region is known as the coal sack. And of course, it's the emblem on our flag, the Southern Cross. Eta Carina, taken with a 13 centimeter f3.3 Takahashi and a typical DSLR camera. So when it comes to astrophotography, you don't need a super flash astronomical CCD camera. You can actually go into Noel Laming's or wherever and get a DSLR camera like a Nikon or Canon I used in this one, and start taking photos with that sort of technology. So it's quite good fun to start getting into it. This is the Horsehead Nebulae. Now this is taken with a hydrogen alpha filter. So basically, with a hydrogen alpha filter, it's revealing the areas of hydrogen gas in the universe that are actually being excited by ultraviolet light hitting the atoms and the electrons jumping up and then jumping down a state. And so it starts emitting light as the electrons jump. So this hydrogen alpha picked up all the nebulosity there, and that's the Horsehead Nebulae. Looks like a horse head, discovered back in, when was it, 1886-ish, by a photographic plate, and named the Horsehead Nebulae not long after that. Now, talking about animals in the sky, for those who know, this is the kiwi, and here's the beak of the kiwi, and here's his head here, and here's his body coming around here, and there's one leg, and there's the other leg, and so that's the kiwi in the sky. And the next photo actually shows you in the Milky Way where it is, and there it is there. There's the kiwi there, so there's his body, leg, head, and beak. And this is Antares. So Scorpius is basically coming around here. So you can see the kiwi is actually quite a large structure on the sky. And interestingly, the Aborigines in Australia see this as an emu. So here's his body, here's his neck, comes up to the coal sack next to the Southern Cross, and here's his legs coming down here. So it's quite an Anzac type photo to have the emu and the kiwi sitting side by side in space. Just other interesting objects in the sky. These are called Bok globules, and this is in Lambda Centauri. It's a nebulae pretty much right next to the Southern Cross, and these areas of molecular dust and cloud and hydrogen that are being compressed, and in time these will be solar systems in their own right. So those are called Bok globules, B-O-K globules. Wide angle picture, the Large Magellanic Cloud is, as some of you all know, there's two satellite galaxies which pretty much, they think, orbit our own Milky Way, and this is the larger of the two. And sitting here is the Tarantula Nebulae, and there is a New Zealand link. Back in 1987, Albert Jones, who was a world famous variable star observer, he lived in Nelson. He was one of the first people on the planet to actually see that a supernova had erupted here back in 1987. So yeah, so good old Albert, got a lot of recognition for that, as you should. Sadly, Albert's passed away since then. Another nice thing to photograph is lunar eclipses. And you can see what's happening here is the moon is actually moving into the Earth's shadow. So you've got the sun, then the Earth, and then the moon. And the moon, as it orbits the Earth, moves into the Earth's shadow. And if you drew that curve out, it's quite interesting. What you can do is what I did in the last eclipse, lunar eclipse, was got a coin, like a 20-cent coin or a 50-cent coin, and moved the coin backwards and forth away or closer to my eye until it matched the curve of the shadow. And then using the rest of the coin, you could actually see how big the Earth was compared to the moon. So it's quite a nice little trick to do during a total eclipse. Galaxies, the Sombrero Galaxy, this was taken through the 35-centimeter Schmidt-Cassegrain telescope. Of course, the moon, always nice to photograph, with all the craters and so on. Measure 42. This is a photograph with a wide-angle telescope in hydrogen alpha filter, with a hydrogen alpha filter, and again you can see the fan shape of Measure 42 sitting here. So basically, this is the sword of Orion sitting here, and down here further would be the belt. So yeah, it's quite a wide-angle photo. That these are a couple of nice galaxies in Leo, Measure 65 and Measure 66. They're actually in a nice place to view in the evening sky now. So yeah, so try and have a look at them sometime. Measure 65 and 66 visually through a telescope. They don't look like this. One problem with photography versus visual observing is that with photography, the camera is building up so much light, and especially when you take like 100 times 3-minute exposures and stack them all together, you really do bring up the light and the detail and so on. But with this, with the naked eye, you just can't gather as much light as a camera can. So these you can see visually, but they don't look like this as nearly as much. They look more like ghostly patches in the sky with a certain amount of structure there. The moon and Jupiter. And actually, can I? It doesn't matter. So a few minutes after this photograph was taken, and this was taken in 2005, the moon covered Jupiter. And if I, yeah, I'll show you the problem. If I zoom in, you can see it there. But when I zoom out again, somehow, oh, no. So I've got to, I can't really zoom in on photos because I seem to lose them. Okay, next target is the Tarantula Nebulae. This was taken with the 41 centimeter telescope. And it's a giant big hydrogen cloud in space where stars are basically being formed. In fact, about 3/4 of the visible universe is hydrogen gas, and roughly the other quarter is helium. And then there's other things like oxygen and so on. But this is basically a huge big hydrogen cloud in space, sitting in the Large Magellan Cloud. So it's what's that, about 170,000 light years away. So it's a fair distance away. They say, I've read somewhere, that if this was sitting where the Great Orion Nebula, Measure 42, was sitting, it would cast shadows. So it's possibly good it's actually that far away, so we don't have light pollution, so to speak. This is Thor's helmet. It's a Wolf-Rayet star, a very energetic star in here, and some nice nebulosity around here. And you can sort of see the top of the dome of the head, and the it looks like a helmet from Viking days. Some of the nebulosity around Eta Carina. This was taken through a hydrogen alpha filter, and yeah, it's just beautiful how much nebulosity there is in space, and especially with hydrogen alpha photography. What you can do is actually be photographing during the day, during the full moon, or if you live in a light polluted area, you can actually photograph from a light polluted area and pick up this nebulosity using a hydrogen alpha. Of course, nothing beats a dark sky, but you can still achieve quite a lot using a hydrogen alpha filter. The Jewel Box in the Southern Cross, a beautiful cluster of stars, and this one here is a very nice red star. And I think it was Herschel looked at it and described it as a beautiful jewel box full of jewels. Centaurus A, the Hamburger galaxy, and basically astronomers think that a couple of galaxies collided and one cannibalized another, ripped it to pieces, and it's quite a strong radio source in the sky. And there's an astrophotographer in Auckland called Rolf Olsen, and he has taken, I think it's about 150 hours of exposure on this particular galaxy, and he's got one of the best photos you'll ever see of Centaurus A.
So, John, I've got a question here.
Omega Centauri, the largest and brightest globular cluster in the sky. Some contend that it's actually not a globular cluster as such, but it's the leftover remains of a dwarf galaxy. But who knows? But it really is a beautiful thing to see, and it's actually at this time of the year, about now, it's actually passing almost overhead. So if you haven't seen it before, get a pair of binoculars and a star chart and try and find Omega Centauri. It's not far from the Southern Cross. It's pretty close to it. And see if you can find it. Or with a telescope with a rich field, it certainly is a beautiful sight to behold. Just to think that each one of those dots is a sun like our own sun, but it's just so far away that the massive big suns just shrink down to these dots. Yeah. Oh, visually. Okay. So, yeah, visually to see color in M42, you can start seeing it probably with with a Newtonian, a reflecting telescope, probably about a 12 inch. Yeah, 12-inch, 14-inch. I've got a 20-inch, and you can certainly see the green colors in Measure 42. It's one of those interesting things. Visually, when you look at it, it looks green, but when you photograph it, it looks red. So it's just one of those interesting things where the cones in your eyes are getting stimulated by enough light to actually start picking up some of the color in Measure 42. Okay, this is the Helix Nebulae. Basically, the star here blew off this layer of gas tens of thousands of years ago, and this will be the future of our sun. Our sun will run out of using its hydrogen and helium and so on, basically reach a point where it can't support gravitation versus pressure, and it will blow off this layer of the outer layers of the star, and there will be a white dwarf basically left over. So very nice object to photograph. Bit of a challenge to actually see visually because it's quite big and quite faint. Now, for those who have just got a camera on a tripod, this is something you could do. You don't need expensive equipment for this. Here's one setting, and for this photo here, I read about this technique that David Malin, who was back in the 70s, 80s, 90s, was probably the world's best astrophotographer. He would take photos like this, and he would slowly, every like 10 seconds, slightly unfocus the lens and keep unfocusing it every 10 or 20 seconds or so on. And the reason for doing this is that it actually shows the colors of the stars quite nicely. If you just look at that, it's hard to tell that it might be an orangey color, but when the light is actually spread out, then you can see the colors. In fact, it's quite a neat little trick to do at the telescope if you're looking at a double star, a binary star, to actually unfocus it to try and bring out the colors in the stars. Okay, this was a photograph a few years ago. It was an alignment of the planets. So there's Gisborne over that way. There's the morning sky. The sun will rise not soon after this. But there was Mercury, Venus, Saturn and the Moon, Mars and Jupiter. So it's not often that you see all the planets sort of lined up on the ecliptic like this. But I like this photo because it shows if I can call it, muscle memory of the solar system when it formed out of the solar nebulae. So as you might know, the cloud basically started. Our solar system was formed out of a cloud, and as it compressed, it elongated, sort of like a Saturn to a degree. Big bulge in the middle, which formed the sun, and the ring of debris out as an accretion disk, and out of that accretion disk, the planets formed in the same plane, on the same plane, and we see this plane here in the sky as the ecliptic. And so these planets are going around the sun as they have done for the last 4.5 billion years. Matariki, the Pleiades, very nice object. And it's a good test for your eyes. About six stars. They can usually see 1, 2, 3, 4, 5, 6. Some can see 7. I think Kepler could see 14 stars. But remember, he was in the northern hemisphere where this thing slid right over the top of him. Whereas for us, it's quite a low object. Of course, the Māori, when they see this rising in the morning in late June, just before the sun, that ushers in Matariki, the new year for the Māori. Astronomers at a astronomy camp, astrophotography camp at Taupo back in 2005, I think it was. Some of my sheep. This was a conjunction of Venus and Jupiter sitting here. It was really hard to actually get to sneak around the sheep to try and get the sheep in the photograph without scaring them and getting the planets in the background. Okay, now for the science that I do here, one thing I do regularly is take photos of comets and asteroids and send these off to the Minor Planet Center. And once they get enough observations, I'll send out these minor planet electronic circulars and tell you what the object is, describe it, and so on. And the next photo will show, it lists the observers. So there I am there, E94 Possum Observatory, and this is what it looks like. Basically, it gives you the object, the date, time, RA, declination, magnitude, and the observatory code, like E94 would be up there a little bit. So astrometry is quite an interesting area to get into, because they might discover an object and not know where it's going. It's kind of like if you took a photo of a cricket ball in the air after it's been thrown. With one snapshot, one photo, you don't know which way it's going. But if you took, say, 5 photographs and you knew the time and the order that the photographs were taken, you're looking at those 5 photographs and where the ball is in each frame, you can actually start figuring out the orbit of the actual, or the trajectory of the actual cricket ball. So too with astrometry, astronomers around the world are taking photos of objects, and I enjoy taking photos of newly discovered objects, and then it helps them determine an orbit. And who knows, one might be heading towards Earth, and it'd be quite neat to be part of a team that got the astrometry for something that's going to go plonk into Earth. So yeah, so that's astrometry. Another thing I enjoy doing with my telescopes is deeply imaging galaxies, and not just taking just short exposures, but taking tens of hours of exposure and then stacking them and really stretching them in Photoshop just to try and bring out any previous cannibalism events that might have happened where a larger galaxy might swallow up a small galaxy. I think there's about 5% of the galaxies in the universe are undergoing cannibalism events, or have undergone events like that. So what I enjoy doing is going around photographing galaxies and then really stretching them just to see if I can find any cannibalism events that might have actually happened. Oh, here's another one. This is a very well-known one. This is the Antennae galaxy. It's in Corvus, and just using a bit of maths. If you know how far away it is and how much of the sky it subtends, then doing a basic mass equation, you can work out that, like, this arm of the galaxy here is about 260,000 light years away. So pretty much double. You could put 2 Milky Ways side by side from here. So these 2 galaxies have actually come into each other, and they're going through the delicate dance of galaxies dying. And as they do, the gravitational forces are throwing off an arm here and an arm there and so on. It's kind of like 2 wrestlers having a wrestle. You see arms and legs splaying out in all directions, and that's what's happening with these galaxies here. And the interesting thing is that in probably about 3 billion years, the Andromeda galaxy will be doing this with the Milky Way, or so astronomers think. Okay, another thing I sometimes do is spectroscopy. So this is a grism, and there's 100 lines per millimeter on this particular type of filter. And I'll put this onto the CCD camera, then take photos through it. So here's the target, and this is the spectra that's made. Now, for those who know spectra, you'll know this should be on the left-hand side. Traditionally, the star is on the left and the spectra is on the right, but this is when I didn't really know what I was doing. But for this here, I was photographing this quasar 3C273, and you can actually see there's little knots of brightness in there. And those are like hydrogen alpha, hydrogen beta lines and so on. And based on the maths, now there's the next question. Yeah. Based on what a star close to us looks like with its hydrogen alpha and hydrogen beta lines, and with the lines of the galaxy, so you can see this line here, hydrogen beta will always be at this many nanometers, but because the galaxy is so far away, it's been redshifted, so that light has been stretched basically, and that's why that line isn't sitting on this blue line. That's why this one isn't sitting there, and so on. So this is called determining the redshift of an object, and the further away an object is, the greater the redshift it is. And by using these numbers down here, the angstroms, and figuring out how much it's been redshifted, it wasn't too hard to actually work out that this quasar was 2.14 billion light years away. So 2.144 billion light years away. So that's an interesting little thing to do too, is get into spectroscopy. And another thing, oh gee, who was it now? Josh mentioned about the microlensing, picking up a planet. Well, there was a team of New Zealand astronomers, Grant Christie, some of you all know, myself, Jenny McCormick, and a 3 or 4 others around New Zealand. We used to do gravitational microlensing, where we would, the Ohio State University, in conjunction with Mount John, would basically tell us to photograph a certain field in the sky for a few nights, and then we'll send the data to them, and then based on that, with the microlensing, they could see that the star increase in brightness as the 2 stars lined up, acting like a magnifying glass. But then as the foreground star moved off being in front of the background star, if there was a little planet sitting just to the side of the foreground star, that also acted as a little magnifying glass. So instead of a very nice bell-shaped curve, you would actually see a bell-shaped curve as the foreground star moved over the background star, and the brightness went up, reached a peak, and then came back down. But the planet itself, sitting to the side, would actually also create a little blip on the side of the bell-shaped curve and show that there was a planet there. And with very good maths and software, the astronomers at Ohio State University could figure out the mass, the distance, and so on to these planets. Now, this one here was quite a famous one, where it was like an Earth-sized planet was discovered orbiting one of the stars within a binary star system. Wasn't very well heard of. Wasn't heard of much that a planet could actually be orbiting within a binary star system, and it was that unique that a paper was published in Science, the journal Science, about that planet, and astronomers rethought how planets are formed in a solar nebulae.
Okay, John, I've got another question.
Yeah.
It's regarding spectroscopy. Do you know what the reason is for using angstroms rather than nanometer for wavelength?
Oh, well, yeah. Oh, gee, there is a reason, and to be honest, yeah, I like nanometers myself, and I think with the software you can actually possibly set it for for nanometers too. But nanometers, basically, you just move a decimal point to the left. So 7,000 angstroms would be like 700 nanometers. That's basically how it works. Yeah, thanks for that question. Okay, now the last little bit is I've just started up an astrotourism business. It's called Gisborne Astrotours.co.nz, and poured a lot of money into getting this telescope. It's a 20-inch f3.9 go-to Newtonian. So basically, you enter the target in the handpad and off you sluice to the target, and got this observatory set up, and got this this room, the shed that I have on my property set up. There it is there, put a nice deck on it and everything, and believe it or not, got it all ready and had one tour, and then we went into level 4. So poured a lot of money into it, and then bang, no customers. So hopefully we'll be out of that soon, and I'll start getting customers. Here's inside the building. It's quite a big building. It's 6 by 8 meters, and it's got a lot of deck chairs. And behind me, with this behind the camera, there's a big screen, and so I just stand up, give the people a talk about astronomy, maybe some of the objects of interest that night, and then we go out to this observatory here. It's quite a large observatory, and we look through the telescope, which has a cover. It looks like that. So it's a nice telescope, nice to use, and there we are looking through the telescope there. These are members of the Gisborne Astronomical Society who came out for a photo shoot, and that's it. So those are my photos. Okay. So maybe perhaps we could answer a couple of questions, and then we can go and look at my telescope that's photographing things, and maybe some people could say what they would like the telescope to slew to, and we'll slew to it and take a photo for you to see in real time. Okay.
Okay. Yeah, there's a bit of a delay between you and what's going out there.
Oh, yeah.
So hence a delay in the questions, unfortunately. If you want to move on to the telescope, I think that will probably be a good idea.
Sure.
And then any other questions that pop up in the channel, I will just interrupt.
Okay. So this is my telescope. I've gone to Type V and C, and it's just photographing what they thought was an asteroid, but then earlier this year, astronomers began to realize there was coma and cometary activity around it. Now, I think this is getting pretty low in the sky. Yeah, it's 12 degrees above the horizon, so it's very low, so the stars look very ugly. But what I'll do is we'll just stop, and maybe I'll tell you what, how about we'll go to one of my favorite objects, and that is Omega Centauri. So this is now seeing the computer screen at the observatory, one of the observatories. So I'll just go NGC 5139, find, and here we go, globular cluster. It tells you the right ascension or the longitude, the declination or the latitude in the sky, and so on. So we'll go slew. And now what you'll see is the telescope, the star chart is showing where the telescope's pointing every second. So it's slewing to Omega Centauri. And so I can actually be sitting here in the house controlling the telescope, which is quite nice if it's a freezing night outside. In fact, a lot of astronomers do this remotely. They might have a telescope in New Mexico, and they might be living in Italy, and they can slew their telescope to targets and take them. Okay, so now hopefully the telescope hasn't gone out of focus too much, but I'll just take an exposure, and hopefully we'll see it. So here's the exposure happening, 4 seconds of 10 seconds, 5, 6, and so on. And there's Omega Centauri sitting there. So we'll just, yeah, no, the focus might be a little bit soft. And we'll get this down to 75%. So yeah, so there's Omega Centauri, the beautiful globular cluster in the sky, and yeah, and so that's how easy it is. In fact, since we're close, we'll just go to NGC 4755, and that's the jewel box, which is quite close to Centaurus A. Omega Centauri. In fact, if I zoom out, you'll see that here's the Southern Cross here. There's the main axis and the secondary axis, alpha, beta, gamma, delta, and the jewel box is sitting just there. And so we'll take a photo of that. and there it is there. It's a little bit off center, but nevertheless you can see the object. In fact, with today's technology, what you can do is there's a number of programs where you can automatically, I'll just save that. Save. So what you can do is tell your telescope this. We'll just tell it to move to NGC 5128. Okay, so that's the Hamburger galaxy, and then we'll take an image, and we'll say 30 seconds and 1 exposure. Okay, and then you can set it so that it could actually take, you know, a few hours worth of exposure, if not more, of exposures, and then you can stack all those photos together, and then stack them together. Let's see. We'll just try. Oh, we'll try Eta Carina. NGC. Oh, gee. 337. Oh, I've just had a bit of a mental. Can't quite remember it, but I think we'll see if that's close to it anyhow. So you've loaded where the object, the telescope slews to, you want to take a photo, and then you go run, start. Then the program's connecting to the camera, connecting to the mount, connecting to the focuser. It's finding the position in the sky where the target is. Now, if we look here, you'll see that it's slewing to, it's slewed to the target already. Starting image delay. And this is the file name. So for the exposure, it'll say NGC 5128, the telescope, the CCD, the RA declination, and so on. And it's taking the photo now. And you can also set it to auto guide too, so it can actually find a guide star and take longer exposures. Okay, and so there is these are some the Hamburger galaxy, NGC 51, Centaurus A, and it's quite amazing that back in the day with film, I'd be sitting at a camera manually auto guiding for an hour or so, just looking at the target. Oops, something's happened. It's stopping for some reason, but anyhow, you get an idea that you can actually set your targets, and it will go all night long, hopefully without stopping like this did. I'll have to figure what happened there, and get a whole night's worth of data and then process it the next day. Back in the old days with film, we would manually put a crosshair like this blue crosshair. You'd look through a different telescope or an off-axis guider, put a star behind the crosshair, and manually be pushing buttons up, down, left, right, and so on to keep the star behind the crosshair with the exposure open for like 40 minutes or an hour or so with film. And then after an hour, you'd stop the exposure and then take more exposures. And sometimes you were sitting there manually guiding, looking, having your eye up to the eyepiece for, you know, an hour per photo for 8 or 10 hours per night. So it was pretty hard. And sometimes the guide scope would actually get in some pretty awkward positions. So you're a bit like an acrobat hanging upside down, manually guiding. Whereas today, it's so easy with guide. You can just take a photo, click on the guide star, and hopefully away it'll go and auto guide, and you can go and do something else. So yeah, so that's basically my presentation.
Okay, I've got another question. Is why do you use a black and white camera opposed to a color camera?
For me, for science, it's better to actually use a black and white camera, because with a color camera, you have a Bayer matrix on it. So you have a on each little pixel, you'll have a green, a red, a green, a blue, and those are all combined to actually make the color image, and that loses resolution. Whereas with monochrome cameras, you get a much better resolution instead of doing that. And if you want to, like, I can actually set this here to take a red exposure now, and say we'll just start a red exposure. It will be slightly out of focus because basically the light path going through the different density will create a different slight difference in focus. But this will be red. Now the interesting, oh, my mount's playing up. Okay, so but nevertheless, through a red filter, the images still look black and white. And if we were to take a blue filter or a green filter or whatever, but then what you do is you can stack them using Maxim DL or another program, and you get the one image which has got the red, the green, the blue, and the detail from the luminance or the clear filter. And that's when you can then combine them all to create the color image. In fact, David Maiden was the person who pioneered that approach back in the a few decades ago.
Another question came up from Ben. He says, question regarding dew. Now it's cold, all his eyepieces find the primary, secondary socket quite dewy quite quickly. What tips do you have on keeping moisture at bay?
Okay, I'll go back to now this is don't anyone do this, but this is what I do. I've got an electric blanket, or I've got a number of electric blankets from, say, the warehouse, like a single electric blanket, and just carefully cut around the edges of the fabric, pull the fabric apart like you're skinning a possum, and then pulled all the white wiring out, and then I just wrap that around the top of the telescope tube, around the tail rad, and so on. And down here is the little controller. You can have 3 settings: low, medium, and high. And that's what I use. Now there are more elaborate, safer methods of doing that. My astronomy mate John Burt once got a zap by doing this method with his telescope. The power landing on the metal tube that was covered in dew, he got a bit of a zap. But so far so good for me. I've been doing this way for like 10 or 15 years and never been zapped. But the responsible part of me is saying go to a telescope vendor like OPT telescopes in California, and they can put you onto getting the proper dew zapping material where it runs off more of a 12 volt, so it's a lot safer and so on. But that's what I do.
Yeah, I think I'll avoid that one.
Knowing
right. My luck, I'll be dead. So we've got a couple of requests of the telescope still running. We've got Southern Pinwheel M83.
Okay, now I hate to say it, I think something's playing up. I'll just see if this will work. M83, find, slew. The mount cannot slew. See the list of reasons below. To cover it, turn the mount off. Wait for a few minutes. I don't know. This doesn't happen often. Of course, it has to happen on the one night when when we're going. I'll just see if I can do it this way. So telescope. Telescope. Disconnect. Startup. Connect. Find home. Drat.
It looks like something's gone wrong
Yeah.
there.
I'm so sorry about this. I don't know what the story is there, but measure 83. I did have taken a photo of it. I'll just see if I can quickly find it. Index measure 83. Oh yeah, there we go there. So these are some of these are old photos. This is taken back in 2005 with a DSLR camera. And so the quality isn't that great. Some of these things I must go through and photograph again. But this is a lovely galaxy to look at and to photograph. You're pretty much looking straight down onto the face of it instead of being an edge-on galaxy. So yeah, a nice spiral galaxy.
Another one that was requested, maybe you've got a photo of it there, is, oh God, I hate saying this name, Rho Ophiuchi Cloud Complex.
Oh, yes. Now, yeah. Okay. So, oh, that's ugly. But there it is there anyhow. That's Rho Ophiuchi there, but it's got this beautiful nebulosity around here. This is a bad photo. I'll see if I can actually maybe find a slightly better one. Yeah, no. And I must admit, I've photographed these things since, and I haven't necessarily put them all in the same folder. This was with an 8-inch telescope f4, and yeah, I think Rho Ophiuchi is sitting pretty much here, but it's overexposed. But you can see some of the nebulosity around there. So it's a very lovely thing. It's basically near the head of Scorpius, so it's certainly viewable now outside if it's clear.
Yeah, no, that looks pretty good there. I must say I've been tossing up about getting one of the black and white cameras as well. It just seems that your resolution seems to be way better.
Yeah.
Let me just check. So I'm not getting any other questions at this stage.
Okay. No, that's good. I'll stop sharing. Okay.
Yeah.
Yep. No, that's fine. Oh, for those who are wondering, this photo here is Eta Carina, and I took that about 3 weeks ago through a 18 centimeter f2.8 Newtonian, and just a typical DSLR camera. And yeah, so that's what you can do with DSLR cameras, and you can do science with DSLR cameras. But like we were saying before, monochrome cameras tend to give you a much more accurate readout and better sensitivity and so on.
If someone wanted to pop around to Gizzy after the lockdown and come and have a look through your scopes, how would they be able to book that in? Or
yeah, oh gee, yeah, if they went to that website, the Gisborne Astro Tours website, so it's gisborneastrotours.co.nz or .com, and I think on there I've got my email. You could actually email me and just say, can I come and have a look or come and join a tour, and I'm sure we could sort something out. So yeah.
Oh, that's great. Well, thanks a lot, John. We really appreciate you coming and chatting to us tonight and showing us your setup. And I was just in Gisborne recently, and if I'd known about it, I would have been there. I think it might have been just before you went and opened up. But definitely when I get back to Gizzy, I will definitely make the trip out that way. So just have a look. I think that's it in terms of the questions. So for everyone else, yeah, thank you for all attending this evening. I'm sure you'll agree it was a really fantastic talk. Thanks a lot, John.
Okay, no, thank you. Cheers.